going to show something else with the controller that I've been showing off with regard to the Crazy Fly. And what I've discovered, and it didn't take me long to make the conversion, what I've discovered is that the simulator that DroneBlocks has out there for Python interaction, and it's kind of a vanilla version of a simulator. It's not the full Crazy Fly simulator, the Mars simulator, any of those things, but it's kind of a more basic model. And then I had become aware of this through some postings, I think, on the DroneBlocks community, and so you know I located where the code was, or this is the code for the simulator, and there hasn't been that many changes to the code recently. Last change was a MQTT fix. And then this is the documentation for how to set up the simulator that's found on PyPy. And I just followed this. I mean, I didn't need to do any kind of sidebars. It just kind of worked. And in fact, I'm using a virtual environment. It's the same one that I'm using to test my Crazy Fly connections on. And then this is the picture of the simulation plane for this more simplified coding simulator. So what I'm going to do is I am going to show the controller. There it is. They're starting up in a slightly different place that I left the previous little segment. I'm going to merge this new one onto the end of the previous one, which allowed me to give an introduction to the simulator. I just want to show the simulator actually in operation. And so I have the coding-sim URL in my browser. I'm allowing insecure content to run here. That's the way that Python can talk to the endpoint here. And I have the movie view here of my controller on the desktop. So I'm going to take advantage of that controller to actually execute the logic inside of the simulator. So if I just go over to where I have my Python, then this is just an adaptation of the motion commander approach that I took with the real Crazy Fly. And I made a video off of that approach just the other day. But now I got interested to see whether or not the controller could talk to the simulation. And I had recalled the URL that I showed earlier in the video here. And it turned out it wasn't hard to make the logical changes based on what I saw in the little demo that is part of the PyPy introduction to the simulation. And so the only thing I'm adding here is the fact that I have a socket interface and my controller is speaking UDP because we're both on the same access point. The controller, I'm going to be using the R4 controller, not the ESP32, but the ESP32 would work just as well. So I have all of the commands that I think are available to me. So up and down, land and take off, forward and back, right and left, and then even yawing, yaw left and yaw right, which I have different signal strings coming in as packets in the UDP. So this is the code, and it's currently not running. So I'm going to start it up over here. So we're listening for packets on the telo port. I've just by previous experience, I'm using that port to make the connection. And then over here is the view of the controller on my desktop. And so let's bring the view of the simulation space with that little drone sitting there. And then let me try to do some operations. So I'll do takeoff. The light blinks while it's waiting for the command and the simulation to complete. When the command completes, the blinking stops. So I took off. I will go up. And that's a fixed distance up. I forget what I have in the code, but it's a very small amount of centimeters. And I can go up again. Oh, Oh, that was a mistake because I pressed the one button, not the up button. Let me go up to up, do it again. And then I can go forward. Again, it's a small amount of centimeters. I can go right. I can go left. I can go left again. And then this perspective view, I'm not controlling that. That just seems to be what the simulator wants to do. And I can do the yaw motion, so I can do clockwise. So that's 90 degrees, and then I can go counterclockwise. Again, 90 degrees. Let me go up a little bit more just because it's fun going up. And then one of these buttons is back again being flipped. So I had bat on the previous Crazy Fly work, and now I repurposed the bat button to be one of the flips. I think this is the backward flip. So I'm going to press bat, which is going to be the flip. And then, so it flipped. I mean, that's what the simulation can do. I can go right again, and then I can land. And I moved ahead, so I'm not back on the dead of the middle of the H there, the landing pad. But that's, I think, good enough. It just shows that this controller is able to operate the simulator. And what I would be interested in doing is to bypass the Python. So this simulator, or sorry, the controller is talking to Python running on my Mac. And since I know what the URL is, and since I don't know a lot about the R4 in terms of what support for MQTT is there, but there's good support for MQTT in the ESP32 environment. And I've used examples in my classes with ESP32 talking MQTT. So I would like to see about maybe making the connection from this controller, not to Python, and then to the world over here, but actually talking directly from the controller, through my Wi-Fi access point, and then off to the internet, which I can do, and make the MQTT traffic go back and forth between the simulation running, at the address that's here, coding-sim.dronebox.io, and then back again to the controller, and not really have to worry about making a connection to Python at all. So let me stop this recording here, and I'll post this to YouTube, and I'll make a little link on the Discord channel.